Hello, our most valued student. My name is Confident and welcome to our 24-minute lesson. In this series of videos, I'm going to take you through the waves, sound and light, and this is for those of you who are doing this term's work, and it's for grade 10 learners. So there is quite a lot that I want to bring to you looking at the topics that I'm going to cover. Let's quickly look at them. We're going to look at the transverse wave pulses. We're going to look at the transverse waves, the longitudinal waves, the sound waves, the ultrasound, as well as the electromagnetic radiation. So I just want you to pay attention to all the videos that I'm going to bring in. There will be a video after the video, a continuation, and you need to follow up on these videos. If you are ready to ensure that you get a distinction in your physical science this term, this is the right time to go through each and every video step by step. Don't cut corners, because remember, there is a distinction on the line. So I just want to promise you, after going through this lesson, in as much as you have done it at school, but trust me, if you go through this, you might not need to follow up a lot, especially when it comes to looking for extra work. This covers everything. So this is a full guide that will cover and take you through your grade 10's work for this term. So let's look at this. Beginning already with the lesson, without going too much, let's look at what is called a transverse pulse. What do we mean when we say a transverse pulse? Now they will need you to define one, and then we're saying a transverse pulse, it is a single vibration traveling through a medium. So now there is three types of mediums you need to know. We have got a medium which is solid, and then we've got a medium which is liquid, as well we've got a medium which is gas. So actually you will discover later that the one that is in gas is slower, and then it increases with the liquid, which increases with the solid. So these are the three mediums that we're referring to when we're talking about a medium. So a transverse pulse, again, it is a single vibration traveling through a medium. And then it says here, sketching of a pulse and the definition of an amplitude. So there is gonna be what I can call you being able to sketch a pulse. They might ask you, remember it's a single vibration, so they might ask you to sketch one. So what are you going to do to sketch a pulse? This is how you can draw a pulse. So it's a single vibration, so you can have a line like that, and then with it you can have something like this. This is a pulse. Now with that being said, when you're talking about a pulse, we mentioned what we called an amplitude. So this is the distance that from that top, the highest point, and then to the bottom. Now I want to label a few things here. We call this line at the bottom here rest, right? It is rest, or it is equilibrium. It is the starting point. All right, so if that line is the starting point, so where is it starting from? It's starting from that point there, which is the rest. So it moves up. You can see it's moving up, it's moving up, it's moving up, and then at that point we call this the highest point of the pulse. So this is the highest point of the pulse. I'll say highest point, and it'll say highest point there. And later when you're dealing with waves, you'll discover that the name given to that is called crest as the highest point. All right, and then the pulse start going down, and then it returns back to rest. Do you see that? So that single disturbance is called a pulse, and the line that I've marked blue, this particular line here, is what we term the amplitude. All right, so this is our amplitude. So they say here we're going to define an amplitude. So what is an amplitude? It is the maximum disturbance of a particle from rest or equilibrium position. Do you see that? So we say you're moving from rest, you're going to the maximum position, and then you are returning to rest. That particular distance that line is called the amplitude. All right, and then next point is superposition. We are saying superposition, the definition there is the addition of amplitudes of two pulses that occupy the same space at the same time. I'm going to demonstrate that. So let me repeat again. If they ask you what is superposition, you are going to say superposition is the addition of what? Of amplitudes of two pulses that occupy the same space at the same time. Are you with me? And then we're saying principle of superposition in a pulse. This happens when two pulses pass each other, and this is termed interference. So every time you see a pulse and another pulse and they pass each other, that phenomenon or that particular term is referred to as interference. And then there's two types of those which you're going to look at. Now, for a transverse pulse, the particles of the medium move at right angle to the direction of propagation of the pulse. So now I'm going to explain that part. Let me actually do that now. If we're talking about a transverse pulse, so we have got, for example, this is a line. Okay, let me start from here. When you're starting a pulse, let's say this is your hand here, this is your hand, and you're going to do a wave like a pulse, a single disturbance. So what you're going to do is you're going to have something like this, right? You're flipping your whether it's a rope, whether it's a string, whether it's anything that can form like a wave. So now this must be kept nicely. So when you do this, say back, now what happens is we're saying the movement of particles. So this is your point A. Let's go to point B. Remember, you flip the rope, so you discover that now the pulse has moved. It is now somewhere here. See that the pulse is traveling. Now let's go to the next point. You're here, and now the pulse is there. So we call that point A, point B, and point C. So this is the pulse that is moving in this direction. Do you see that? So now look at the particles, how they are moving. So we are saying here the particles are moving at right angles, meaning at 90 degrees. So we're saying the pulses for a transverse pulse here, the particles of the medium move at what? At right angles to the direction of the propagation of the pulse. So what we mean by that is, look at the direction of the pulse. As you can see, this is the one that is moving in this particular direction. We're saying that's the direction of the pulse. Now, how are the particles moving? They are at right angles, and right angles, it means that where there is a 90 degrees. So you see, the particles, remember, the medium here is the rope. That's we said solid, liquid, and a gas. So here, if it's a rope, it means it's a solid. So the particles are moving like that. You see, so that's the beginning, and after the maximum point, the particles start moving down. You see that? But the direction is always from left to right. Similarly here, they continue like that, and the particles move down. So you can see that the particles are moving up and down, and the pulse is moving from left to right. It is transferring energy, as you can see, as you move from left to right. So that's what we mean when we say it for a transverse pulse, the particles of the medium move at right angles to the direction of propagation. So what you're going to be having, you're going to be having something like this to say, when you kind of sketch it, this is the direction of pulse, all right, and then this is the direction of what? Of particles, all right. They are at right angles to each other. Then there is that 90 degrees that we're forming. So that is that part. So remember that. And then as we continue, here we are saying, let's look at the pulses moving on the same side, which is called constructive interference. And then the definition of a constructive interference is what we're going to look at. So let's look at constructive interference when it comes to the pulse here. Now with constructive interference, we said when pulses move together, so there is a special line of reference here. Let's say I've got a line of reference here, and the pulses are moving together, and let me do that. And then we are saying you have a pulse, see that, and I have another pulse. Okay, let me make it actually a different amplitude. Let's say this particular pulse is more bigger than the other pulse, and then let's call the amplitude of this pulse from here, the amplitude, we're gonna call it let's say A. Remember, what is the amplitude? It is the maximum distance from rest. So you can see that this position, we call it rest or equilibrium. There is no movement of the particles, and then that point is called the maximum point. I said we call it crest, right? And then again, there is another, this pulse is moving. Let's put a direction. This is the direction of that pulse, and then we've got a pulse that is moving also in the opposite direction, and the distance here, the amplitude, remember we call it the amplitude, let's call that distance B. So when you look at the arrows, these pulses are going to meet, so we will call this one A, and then we call this one B. So you've got these two pulses, they want to meet, and we are going to accept that they meet at that point, and then let's call that meeting point M. Now the question is, what is going to happen at point M? So this is what you need to remind yourself. When you're drawing this pulse, you're going to have that point M. Let's do that again. And at point M, when these two pulses meet, just a moment, just a little bit. So this is what is going to happen. Both A and B, they are going to add up like that. See what we're going to have? And the amplitude now of this particular pulse is going to change. It is no longer the A or the B, but it is a combination of both, which is take A and you add B. Now that is the distance of the new pulse. Are you seeing that? So that is that. So you are taking the pulse A, you're taking the pulse B. So where they meet, which is that point M, remember we called this point M. This meeting or the combining together, we call it interference of the pulses, but it's got a special name. We call this one constructive interference. Constructive interference. And from here we can define what is constructive interference. It is the combination of two pulses which are what? Which are moving in the opposite directions. It's the combination of two pulses which are on the same line but moving in the opposite directions. That is the constructive interference, meaning they construct each other. From that word construct, they build each other up. So when you look at A is shorter, and you look at B is taller, but you look at A and B, you get even a bigger pulse, which is a combination of A and B. Let's make an example. If my A, for example, here was 2 centimeters, and my B here was 3 centimeters. Now, what is the new pulse? It will be A plus B, which is 2 plus 3. So you're going to draw a pulse, which is what? 5 centimeters. Are you getting that? So that is how the whole part on addition of pulses in constructive interference it means. And then after that, we have the next part continuing, pulses moving in the opposite direction. What is called destructive interference. So these are the pulses that move in the opposite direction, and then we're going to define that. So when we're talking about destructive interference, again, similarly, the concept doesn't change. You have got pulses. I'll have them like that, and with that I will have two sorry about that, like that. So we have a pulse, for example, one is moving similarly like what we did, is moving on top, and then we will call that pulse our pulse A, the amplitude there. Let me use a different one. So let's say I've got an amplitude here. So what is this amplitude? It's A, so it's moving in that direction. We call it pulse A. And then I've got pulse B. Now look at pulse B, it's moving in the opposite direction, and it's like that, whereby B is bigger than A. That's what I want you to see. You can see that our B is much longer than A. So I've got my B. So this is the different direction we talk about, and then B is moving in that direction. The question is, if these pulses are to meet at that point M, what is going to happen? So you're going to have two pulses. Let's draw again. Combining, remember the combination, we called it interference. So that particular interference, because they are moving in different what? They are moving in different directions, and they are on the same line of action. You can see that we had a same line here. This is our same line, a horizontal line. The point of rest is the same. So this pulse, one moving on top and the other one moving at the bottom, but on the same line of action, when they meet, now they are not going to construct each other, they are going to destroy each other. That is called destructive interference, and the resultant pulse is going to be even smaller. So you have a pulse like this. So that is that. You get a pulse. I just wanted it to make it even smaller than that. So you get a pulse like this, which is even smaller than a combination of two. And you see the resulting amplitude there. That amplitude is what? It's even smaller. So how do you get the amplitude? If B was bigger, you're going to take B, you subtract A. So for example, if A, as we said previously, it was A was equal to amplitude there was 2 centimeters, and the amplitude of B was 3 centimeters. What is the resultant? So you're going to say 3 minus 2, which is equal to 1 centimeter. So this amplitude is 1 centimeter. You see that? So that is how we describe, what is this called? Destructive interference. They are interfering, but they are destroying each other. So that is that part. So what is the definition we can put here of destructive interference? It is when two pulses meet together, traveling in the opposite directions, in the opposite line of action, and they destroy each other. I'm going to show you later when we look at pulses that are of the same size, same amplitude, and they are moving in opposite directions, what happens to such pulses. Alright, and then here look at this. It says apply the principle of superposition to pulses to explain using diagrams how two pulses that reach the same point in the same medium superpose constructively and destructively, and then continue in the original direction of motion. So this is very important. Now don't lose me here, pay attention. They will ask you that. Look at this. They are saying we have got two pulses. You need to explain the principle of superposition. Remember this principle where pulses come together and they form a bigger pulse, or they destroy each other. We call that principle superposition. So we are explaining it using diagrams, how two pulses that reach the same point, they reach the same point in the same medium, they superpose what? Constructively. We will start by that, and then later destructively. So we have got two pulses here like this, and these pulses, for example, they are moving, as we said, I'll make them similar. Let's say you've got A. See, so this is the same, the amplitude is the same place. Here you have got the amplitude of A, so in the other one you've also got the amplitude of A. So these are the same size of pulses, so they are moving in the same medium. But look at this, don't forget, this one is moving this direction, this one is moving this direction. They are two produced pulses in the same medium, right? And then, so let's call this one A, let's call that one B. And then after that, the pulses when they are about to meet. So what you are going to have, you're still going to have a similar part of the here. Now they are about to meet. So what you have, I just want something here like this that shows these two pulses. You see, they're about to meet. Now going this direction, going this direction. Don't forget, this is my A, that is my B. It's same amplitude, right? And then when they meet, now we said when they meet it's similar, but constructive interference. Remember, they build each other up. So when they meet, you are adding what? That A here. If it was A, the amplitude was A. So what do you have? You have got two pulses that combine like this. And this distance here, what is A plus A? Remember, you're adding, it is 2A, right? So that distance is twice 2A. That is when they meet. And then after that, you're going to say what? After they meet. So in a way, let me just show you what this would have been. If we're using two different colors, you're going to say, okay, I've got this pulse like that here. See it? And then there it is here. So here there is a combination of the pulses, but now after passing each other, where am I going to find A and B after they meet? So we're going to have it like this. So now just after meeting, you still have something similar to the previous diagram we drew. So you got this and you got this, but don't forget my B now is this side. Remember, that is now my B because it was moving this direction and A is continuing this direction. A and B, you see that? And then after that, after long time after they have met, you're going to have what? Similar, like at the beginning, this pulse is there, this pulse is there, and then you can guess where is B. So B is somewhere here now, and the other one is what? Is A. Do you see how it's like? And where is B going? B is going this direction, and this one is going this direction. So that is the pulses, how they say here constructively, and then they continue. It says how pulses reach the same point at the same medium, superpose constructively and destructive, and then continue. Now let's look at the destructive interference. We're going to compare the two. Destructive interference, I will have to draw it a little bit in the center. Remember about destructive interference, we say these pulses, they move from different directions. So you've got this pulse, which is our medium, is the same, and amplitude is A, and you've got a similar pulse, and the amplitude here is A. So moving in the opposite direction. So this is my A, this is my B, and I would like to maintain my B as this part. Right, then we continue. After the what? After these pulses are the pulses when they are about to meet. So you still the same thing here. These pulses are about to meet. So they're just close to each other. And don't forget, A is on top, and where is B? B is at the bottom. And don't forget the arrows, they're just about to meet. Same thing, going this direction, going this direction, and that's my A and that's my B. Now if the amplitude is A and the other amplitude is A, now when they meet, we're now in C. What happens when they meet? Remember, when they meet, you're just going to say A minus A, because one is on top, one is at the bottom, and you get 0. So when they meet, how do you represent that? You just represent with a straight line. They're going to cancel each other, and when they cancel each other, they're just going to form a straight line. Are you with me? And then you're going to have just after they meet. So this is what is going to happen just after they meet. You're having them here and here very close to each other. And don't forget now, where is B now? B is on the other side. See that? Because they just met. And where is your A? A just passed the other side. So this is your A and this is my B. I sing that. and then long after they have met, you are still continuing with your pulses, and then return now to say some distance apart. But where is your B? Your B is further that direction. And where is your A? Your A is in that direction. So this is continuing. What do you have? I've got my A. This is continuing. I've got my B. So you look at the arrows on both sides. In the beginning, if I can have even my B there, you see A and B on both constructive and destructive interference, they move towards each other. The arrows are facing each other. The arrows are facing each other. Then after they meet, well, that is the interference point. So this is the part of interference here. And superposition takes place. Here is constructive interference. Here it's destructive interference. That's the superposition that we're talking about. And then just after they meet, look, the arrows are now facing in different directions. All right, so that's what they wanted to bring in there. Now, just to wrap up this lesson, I just want to bring in a few things that you might need to also know about the pulses. Uses of the superposition principle. They're saying, where do you see superposition in real life? It is used in the design of music or concert halls. So remember that when they are designing concert halls, sounds produced from any musical instrument like a guitar, a piano, it uses the principle of superposition. And then electrical engineers use it to design complex circuits. Mechanical engineers use it when they're designing structures like beams. Let's look at a simple activity here. It says two pulses X and Y move towards each other at the same speed. The amplitude of pulse X is 1,8 meters and the amplitude of pulse Y is 1,2 meters. The pulses meet at point R. So look at the directions. The amplitude, you can see 1,8 for point pulse X. There it is. Remember, what is the amplitude? From the top to the rest, that's the distance. They meet at point R. Look at the arrows, they are opposite each other. Now they says define a pulse. We just did it. What did we call it? A single disturbance in a medium. So this is what? A single disturbance. Right. So that's what we said. Through a medium. And then says, what is the name given to the type of interference that occurs at point R? Remember, we said when they meet at point R, in general is called interference. And you have got two types. You have got constructive interference and you have got what? Destructive interference. So now what do you think is this type? The moment they are in the opposite direction, one is on top, one is at the bottom, you deal with destructive. Why? Because you're going to subtract one from the other. In this case, X is bigger, it's going to be like 1,8 minus 1,2. You don't add them. So when you're using subtraction, it is destructive interference. Are you with me? Then it says, draw the resultant of the two pulses at point R and then indicate the resultant amplitude of the pulses in your diagram. Now draw the resultant of the two pulses. This is 2 marks. You ask yourself, which one has the bigger amplitude? You can see that this pulse has the bigger amplitude. It's 1,8. And now if you subtract, as you said, 1,8 minus 1,2 is equal to what? 0,6. Because these pulses are going to subtract each other when they meet. So now when you draw a diagram, you're going to draw a pulse like this. And you must ask yourself, is this pulse going to be at the bottom or at the top? Look at the bigger pulse, it's at the top. So 1,8 is at the top, so the difference there when these pulses cancel each other is also going to be at the top. So you're going to have a pulse like this. And that distance there, they expect to know that distance there. Alright, just like they did in the other one, but you must tell us that this is 0.6 meters. This is what the destructive interference I'm doing. So it says draw resultant of the two pulses, indicate the resultant amplitude of the pulse. So there it is, right? And then you might have even gone further and say show the pulses just after they meet. How do you expect them? Just after they meet, you will have these two pulses like this just after they meet. Now in here you have that pulse, and here you have that pulse. What is it? This is the pulse which was what? 1,8 meters moving that direction. See that? Because they just passed each other. And then the other one, y, so this is your x here, and then the y now, this pulse which is 1,2, it is moving that direction. You understand? So that is that which you can expect when you are dealing with pulses. So we have come to the end of our lesson here where we're looking at pulses. I had to just stretch it. I know it's a 24-minute lesson. I have to stretch it just to finish up on pulses. But the next important lesson, don't lose me now. Pay attention. The next important lesson is a lesson where we're going to now introduce the topics of waves, where we look at the transverse waves, the longitudinal waves, as well as later the electromagnetic waves. This is what you don't want to miss. You need to watch the next lesson because it is going to build up on the previous lesson we just did. Now, easier for you, I will encourage you to subscribe to this channel. If this is your first time, ensure that you are subscribed to the 24-minute. Also share it with your friends. Remember, this is your ultimate guide to a distinction. If you just want to get a distinction, I will encourage you. This you need to follow up. Every time you are stranded, come back to this channel, but you can do that if you are subscribed. You will never miss any channel. Every time I'm posting a video, you are going to be notified. So towards your June exams, towards your November exams, I post some videos just to prepare you for the final exams. How are you going to get these notifications if you do not subscribe? If you are subscribed, every time I post something, there's a lot of different subjects I'm posting, but you just look. If the notification says physical science grade 10, you know it's yours. If it says something different, you just ignore it. There is no harm, but make sure that you're subscribed. Join me in the next lesson. Thank you.